The lunar surface lies silent, marked by micrometeorites and Apollo footprints, the last from 1972. Though Apollo retrieved 842 pounds of lunar rocks, political shifts and budget cuts eclipsed its legacy as NASA pivoted toward Mars. Now, after 53 years, the silence is set to break. If you feel that same tension, that pull towards something we're not supposed to see, hit like, subscribe, and comment your thoughts. And if you want others to join us on this journey, share the video, X, Facebook, Reddit, anywhere you can. You're the reason stories like this reach beyond the algorithm. Thank you for being awake. 4 astronauts, 2 men and 2 women, are preparing to return to the moon, aiming to build infrastructure for sustained human presence. Their mission includes constructing habitats and rovers to endure the lunar night, where temperatures plummet to 280 degrees. This effort is more than symbolic. It's a race to secure a permanent foothold beyond Earth. The moon holds critical resources like helium-3 for fusion energy and water ice for life support. Water found in shadowed polar craters could fuel Mars missions, turning the moon into a refueling hub. While Earth's crises dominate headlines, engineers worldwide are quietly preparing for lunar habitation. The moon, once a Cold War prize, is now a gateway to Mars and a laboratory for solar system exploration. Time is short and delays shrink the margin for error. A landscape of stark beauty and ancient secrets, the moon offers a frontier for humanity's future. It is both an asteroid impact graveyard and a museum of solar system history, with rocks older than any on Earth. The question lingers: whose footprints will define this new chapter? Will it be NASA's Artemis program, aiming to land the first woman and person of color on the moon by 2025, or China's taikonauts backed by rapid advancements? The race is on, and the moon's silence will soon resonate with the voices of a new generation of explorers. Part 1. The Long Absence. Imagine 53 years of absence. The last human footprints on the moon belong to Gene Cernan and Harrison Schmitt, who left them in December 1972. They departed the lunar surface unaware that over half a century would pass before anyone followed. This gap is longer than the period between the Wright brothers' 1903 flight and Neil Armstrong's lunar step in 1969. The moon's dust has settled into an untouched layer, a silent record of humanity's pause. Since Apollo 17, no human has ventured beyond low Earth orbit, just 250 miles above the planet. The International Space Station, ISS, has orbited Earth since 1998 but never breached this boundary. Astronauts have circled the planet over 100,000 times, yet the moon, just 238,885 miles away, remains untouched. This absence reflects a void in ambition, a pause in the drive that once defined the space age. But the silence is about to end. Astronauts are preparing, their spacesuits more advanced than Apollo's A7L suits. Rockets are being assembled, their towering frames dwarfing the engineers inspecting them. The spacecraft Integrity stands ready to carry humanity farther than it has traveled in generations. This vessel embodies hope and renewed ambition. The question remains, why now? And why does this mission matter more than any other in recent memory? The answer lies in the future. The moon is no longer just a symbol, but a stepping stone. A race has begun, with stakes higher than the Cold War competition between the United States and the Soviet Union. China, India, and private companies like SpaceX and Blue Origin are vying for a foothold on the lunar surface, driven by resources, scientific discovery, and strategic advantage. The moon, once a distant dream, is now a tangible goal, and the race to claim it is intensifying. Observation. The absence of human presence on the moon was not due to a lack of interest or capability, but shifting priorities, budget constraints, and technical challenges. The Apollo program, while groundbreaking, was unsustainable, relying on disposable rockets and limited technology. Interpretation. The resurgence in lunar exploration is driven by advances in reusable rocket technology, the discovery of water ice on the moon's poles, and the moon's strategic importance. The Artemis program aims not just to return humans to the moon, but to establish a sustainable presence there, paving the way for missions to Mars and beyond. Speculation. If successful, the Artemis missions could usher in a new era of human space exploration, characterized by collaboration and long-term vision. Technical challenges, geopolitical tensions, and unforeseen complications could still derail these plans. The moon, once a symbol of unattainable dreams, is now a proving ground for humanity's future in space. Part 2. The Rocket and the Crew. The Space Launch System, SLS, is NASA's most powerful rocket, producing 8.8 million pounds of thrust, 15% more than the Saturn V. At 322 feet tall, it awaits liftoff at Kennedy Space Center's Launch Complex 39B, the historic site of Apollo and Space Shuttle launches. Topped by the Orion spacecraft, it will carry the Artemis II crew to the moon, a destination unvisited by humans for over 50 years. Its 4 RS-25 engines, veterans of 25 Space Shuttle missions, are now upgraded to operate at 109% of their original thrust. The Artemis II crew consists of Commander Reed Wiseman, pilot Victor Glover, Christina Koch, and Canadian astronaut Jeremy Hansen. Together, they bring over 660 days of spaceflight experience and thousands of training hours. Wiseman spent 165 days on the ISS and conducted 2 spacewalks. Glover, who piloted the SpaceX Crew Dragon, completed 168 days in space. Koch holds the record for the longest single spaceflight by a woman at 328 days and participated in the first all-female spacewalk. Hansen, with over a decade of training, served as a capsule communicator for NASA missions. Artemis II is more than a mission. It's a test of technology and human endurance. The crew will travel 230,000 miles in a figure-8 trajectory around the moon, covering 1.4 times the lunar distance over 10 days. They will test Orion's life support and navigation systems, which must recycle oxygen, scrub carbon dioxide, and guide the spacecraft with precision. The heat shield at 16.5 feet in diameter will endure temperatures exceeding 5,000 degrees Fahrenheit during re-entry. Behind the crew is a global team of over 10,000 professionals who have refined every component of the SLS and Orion. Mission Control in Houston will monitor the mission, with support from the European Space Agency and the Canadian Space Agency. The European Service Module, built by Airbus, provides Orion's power, propulsion, and thermal control. This mission will pave the way for Artemis III, aiming to land the first woman and next man on the moon by 2025, with the goal of establishing a sustainable lunar presence. It's about the human element, how we work together, adapt, and overcome, Wiseman emphasizes. As the countdown begins, seconds, the SLS will consume over 700,000 gallons of propellant in its first 8 minutes, shaking the ground for miles. The launch will mark a new era of exploration, a step toward Mars and a leap into the unknown, carrying the dreams of a generation that envisions a future beyond Earth. Part 3. The Unseen Competition. In 2024, Chang'e 6 collected rocks from the far side of the Moon's South Pole Aitken Basin, revealing insights into lunar geology and potential water ice deposits. China's plans include building the International Lunar Research Station with Russia, a permanent lunar base slated for completion by 2035. This base will support long-term habitation and research, with modules dedicated to lunar geology, astronomy, and low-gravity effects. Meanwhile, China is developing the Long March 10 rocket, capable of lifting 70 tons to low Earth orbit and 27 tons to lunar transfer orbit, rivaling NASA's Space Launch System. Leaked simulations of Chinese landers highlight the intensity of the ongoing lunar race. Additionally, China is pioneering technologies like 3D printed habitats and solar-powered rovers for lunar operations. The US faces significant competition as the stakes involve not just scientific discovery or national pride, but strategic control of space. China's advances have raised concerns in Western intelligence, suggesting Beijing seeks not only a scientific outpost but military and economic dominance over cislunar space, the region between Earth and the Moon. This competition is about securing resources, controlling orbits, and shaping humanity's future beyond Earth. Private companies are also reshaping the landscape. SpaceX, led by Elon Musk, is developing the Starship system for Mars missions, but aims to land on the Moon by 2025. Blue Origin, founded by Jeff Bezos, is building the New Glenn rocket and Blue Moon lander to transport payloads and humans to the lunar surface. These ventures are redefining space exploration, challenging traditional players, and accelerating innovation. Observation. The lunar race is no longer just between the US and China. Private companies, with their rapid development and funding, are emerging as game changers, capable of disrupting the status quo and redefining possibilities. Speculation. If China establishes a permanent lunar base before the US, it could gain a strategic edge that may be difficult to overcome. Control of the Moon's resources, particularly water ice for fuel, could determine leadership in the next phase of human expansion into the solar system. Part 4. The countdown to launch. The clock is ticking. On October 18, 2025, at Kennedy Space Center, a crane carefully placed the Orion spacecraft onto the Space Launch System, SLS, rocket, marking the end of years of preparation. The delicate operation, watched by over 200 engineers and specialists, signaled the transition to launch readiness. The journey to this point has been challenging. After Artemis 1 in 2022, microfractures were found in Orion's heat shield, leading to over 1,200 hours of redesign. The life support system also required adjustments after simulations showed potential failures under extreme solar radiation. Meanwhile, the advanced spacesuits designed with Prada faced delays due to integration complexities. In the coming weeks, the Artemis 2 crew will undergo a full dress rehearsal, simulating every launch day procedure and emergency protocol. This includes a 48-hour countdown sequence with the crew spending over 10 hours in their seats. Ground control will test their response to over 20 potential emergencies, raising the question, will they and the technology they rely on, be ready. The SLS rocket, standing at 322 feet and capable of generating 8.8 million pounds of thrust, is an engineering marvel. However, its development has faced cost overruns and delays, with the budget exceeding $20 billion. Critics argue it's an outdated design, but NASA insists its proven technology is crucial for Artemis missions. As the countdown progresses, pressure on the ground crew intensifies. Over 500,000 gallons of cryogenic fuel must be loaded into the SLS within 7 hours. Any delay could scrub the mission, costing millions and setting the program back. The Artemis II crew, Commander Reed Wiseman, pilot Victor Glover, and mission specialists Christina Koch and Jeremy Hansen, will watch, their anticipation and anxiety growing. The countdown is more than a technical milestone. It's a psychological one. For the crew, it's the culmination of lifelong dreams. For NASA, it's a chance to reclaim past glory. For the world, it's a reminder of human potential. But as the clock ticks down, the stakes grow higher, and the margin for error shrinks. Success will depend on both technology and the courage of the people behind it. Part 5. The Flyby Mission. Artemis II is not a landing mission. The astronauts will travel to the moon, loop around it, and return to Earth. It may sound simple, but it is anything but. This mission is a critical test of the systems that must work flawlessly for later crews who will actually land on the surface. Every bolt, every circuit, and every line of code will be scrutinized under the harsh conditions of deep space. The success of this mission will determine the viability of future endeavors, including the establishment of a permanent lunar base. The journey will last approximately 10 days, a duration that will push the boundaries of human endurance and technological reliability. The astronauts will fly farther from Earth than any human has ever traveled, reaching a point about 4,600 miles beyond the Moon before looping back. This distance is more than twice the farthest point achieved by the Apollo missions, which reached a maximum of 2,234 miles beyond the lunar surface. Along the way, they will test the Orion spacecraft's systems, ensuring that everything from the heat shield to the parachutes functions as designed. The heat shield, in particular, will face temperatures exceeding 5,000 degrees Fahrenheit during re-entry, a trial by fire that will determine whether the spacecraft can safely return its crew to Earth. But there's more to this mission than just the astronauts. 5 small satellites called CubeSats will be deployed during the flight. These tiny spacecraft, contributed by international partners like Germany, Argentina, South Korea, and Saudi Arabia, will conduct their own scientific investigations. While the crew continues toward the Moon, these satellites will study everything from space radiation to electrical components in lunar conditions. One of the CubeSats, for example, will measure the impact of solar radiation on electronics, a critical step in designing more resilient systems for future missions. Another will analyze the lunar surface for water ice deposits, which could one day support human outposts on the Moon. The Artemis Accords, signed by over 40 nations, establish principles for peaceful lunar exploration. This is cooperation on a global scale, but it is also a test of technology and human ingenuity. The question is, will it be enough to secure humanity's future in space? Each partner nation brings unique expertise and resources to the table. Germany, for instance, has contributed state-of-the-art propulsion systems for the CubeSats, while South Korea has developed advanced lunar imaging technology. This collaboration not only strengthens international ties but also accelerates the pace of innovation. Observation. The Artemis II mission is more than just a technical demonstration. It is a symbol of what humanity can achieve when united by a shared goal. The astronauts, hailing from diverse backgrounds, will work together in one of the most isolated environments imaginable. Their actions will be watched by millions on Earth, a reminder that space exploration is a collective endeavor. Interpretation. The success of Artemis II will depend not only on the reliability of its technology, but also on the resilience of its crew. The astronauts will face psychological challenges, including the stress of isolation and the pressure of performing complex tasks in zero gravity. They will also endure physical strain, as the human body is not evolved for the rigors of space travel. Muscle atrophy, bone density loss, and radiation exposure are very real threats, mitigated only by cutting-edge medical research and in-flight countermeasures. Speculation. If Artemis II succeeds, it will pave the way for a new era of lunar exploration. Future missions will build on its achievements, sending larger crews and more advanced equipment to the moon. Eventually, humanity may establish a permanent presence on the lunar surface, using it as a stepping stone to even greater destinations, Mars, the asteroid belt, and beyond. But for now, all eyes are on Artemis II, a mission that embodies both the ambition and the uncertainty of humanity's quest to become a multi-planetary species. Part 6. The Lunar Gateway. Imagine a space station orbiting the moon, a testament to human ingenuity in the cosmos. The Lunar Gateway will trace a near rectilinear halo orbit, balancing Earth's and the moon's gravitational pulls. At its closest approach, it will be 3,000 kilometers from the lunar surface, enabling detailed observations and quick surface transit. At its farthest, it will reach 70,000 kilometers, the deepest any human-rated craft has ventured, opening new opportunities for deep space exploration and radio astronomy. The Gateway's initial modules, the Power and Propulsion Element, PPE, and the Habitation and Logistics Outpost, HALO, are slated for launch by December 2027. The PPE, with advanced solar electric propulsion, will generate 50 kilowatts to power the station and drive its precise orbital adjustments. HALO, with a 12 cubic meter habitable volume, will serve as the command center and living quarters, offering docking ports, labs, and a staging area for lunar missions. The Gateway embodies global cooperation. Canada is developing the Canadarm3 robotic arm for assembly and maintenance, while the European Space Agency, ESA, is building the iHabi module to expand living space. The United Arab Emirates, UAE, is enhancing communications. This coalition supports NASA's Artemis program to land the first woman and next man on the moon by 2025. Paving the way for a permanent lunar presence. Challenges remain, from extreme temperatures 156 degrees to 123 degrees, to micrometeoroids and radiation. Partners must develop advanced technologies like regenerative life support and radiation-resistant materials, while coordinating international efforts and managing political priorities. Time is critical. China, India, and companies like SpaceX are racing to the moon. The Gateway's success could define the future of space exploration, establishing a sustainable lunar presence and serving as a proving ground for Mars missions. As launch nears, the stakes are high. Its success could inspire future generations to push the boundaries of exploration even further. Part 7. The Commercial Players. While NASA and its international partners develop the Lunar Gateway, private companies are already making strides toward the Moon. The Commercial Lunar Payload Services Program, CLPS, marks a shift in NASA's approach, outsourcing spacecraft operations to private entities to focus on research and exploration. This model, successful with commercial cargo and commercial crew for the ISS, leverages private innovation and cost efficiency. By 2023, NASA awarded over $6 billion in contracts to more than a dozen companies under CLPS, with missions planned through the decade's end. In February 2024, Intuitive Machines achieved the first American soft landing on the Moon since Apollo. Their Odysseus lander, despite a rough touchdown, collected valuable data in the lunar South Pole region, carrying 5 NASA payloads, including a laser retroreflector array and a spectrometer. Since then, companies like Firefly Aerospace and Astrobotic have launched missions, enhancing our lunar understanding. Firefly's Blue Ghost lander delivered 10 payloads to Mare Crisium in September 2024, while Astrobotic's Peregrine carried 24 payloads to Lacus Mortis in December 2024, including rovers and scientific instruments. These missions carry risks. In March 2025, Intuitive Machines' second lander, Athena, failed during descent, highlighting lunar landing challenges. Extreme temperatures, abrasive dust, and unpredictable terrain make the lunar surface unforgiving. Yet, data from both successful and failed missions refines technologies and improves spacecraft resilience. Observation. The commercial lunar sector includes diverse players, from aerospace giants like Lockheed Martin to startups like Orbit Beyond, which secured a CLPS contract in 2019 with fewer than 20 employees. This diversity drives competition and innovation, with companies exploring new propulsion systems, landing technologies, and 3D printed components. Interpretation. The commercial lunar sector aims to build a sustainable lunar economy. Companies like Marston Space Systems are developing technologies to extract lunar resources such as water ice to produce fuel for spacecraft. This could reduce mission costs, enable longer duration exploration, and support human habitation on the Moon. Speculation. As the commercial lunar sector grows, it could ignite a corporate space race. SpaceX and Blue Origin have announced plans for lunar landers and habitats, with SpaceX's Starship aiming to carry humans to the Moon by 2025. This competition could accelerate space technology innovation, mirroring the early commercial internet's rapid advancements. More missions are planned, bringing us closer to a future where the Moon is a workplace, laboratory, and potential home. By 2030, NASA envisions a sustained human presence on the Moon, with commercial partners key to transportation and habitat construction. The Artemis Base Camp concept includes a lunar surface habitat, rovers, and a lunar terrain vehicle. Companies like Icon are designing 3D printed lunar habitats using local materials, positioning the Moon as a hub of human activity, a stepping stone to Mars, and a testbed for technologies enabling life and work beyond Earth. Part 8. The Race to the South Pole. The lunar South Pole is the most coveted region in the inner solar system, potentially holding the key to humanity's future in space. Billions of years ago, water ice was deposited there by comets and asteroids, remaining frozen in permanently shadowed craters. These reserves could provide drinking water, breathable air, and rocket fuel for lunar inhabitants, revolutionizing space exploration. NASA's 2009 L-Cross mission confirmed vast deposits of water ice in the Cabeus crater alone, enough to fill tens of thousands of Olympic-sized swimming pools. The South Pole covers approximately 386,000 square kilometers, with craters like Shackleton and Faustini harboring similar ice deposits that could sustain lunar bases for generations. The South Pole's value extends beyond its water resources to its unique environment. Temperatures drop below 200 degrees in the shadows, yet certain crater rims or peaks of eternal light receive near constant sunlight. These illuminated areas could host solar power stations providing uninterrupted energy for lunar bases. Robotic rovers could mine water ice from nearby shadows, enabling sustainable long-term habitation and reducing mission costs by eliminating the need to launch fuel from Earth. NASA estimates that extracting water ice on the Moon could cut fuel transport costs by up to 90%, making extended missions more feasible. The race to harness these resources is intensifying. NASA's Artemis program aims to land astronauts at the South Pole by 2025, while China's Chang'e program plans to send taikonauts by the early 2030s. The goal is not just national pride, but securing access to resources critical for future missions to Mars and beyond. Whoever establishes a permanent presence first could gain a decades-long advantage in space exploration. Companies like SpaceX and Blue Origin are also targeting the South Pole, with plans to support NASA's Artemis missions and develop commercial infrastructure, including lunar landers and habitats. The stakes are high. The resources at the South Pole could fuel not just lunar settlements, but also missions deeper into the solar system. Observation. The South Pole's extreme conditions, temperature swings, abrasive lunar dust, and lack of magnetic protection make it challenging but not insurmountable. Its resource potential has ignited a modern space race, driven by the pursuit of a sustainable future beyond Earth. For instance, the Shackleton crater, with its towering peaks and deep shadows, exemplifies the South Pole's potential and challenges. Its rim receives almost continuous sunlight, while its floor remains in perpetual darkness, harboring ice deposits and simulating the extremes of space exploration. Speculation. Control of the South Pole's resources could define who leads humanity's next great leap into the cosmos. The race is not about planting a flag, but building a foundation for interplanetary exploration. The nation or coalition that secures the South Pole will shape the future of lunar habitation and set the stage for humanity's expansion into the cosmos, determining who writes the next chapter of space history. Part 9. The Chinese Ambition. Tons of ice. Chang'e 7 will map these resources and provide subsurface data, crucial for future human outposts. The Chang'e 8 mission, slated for 2029, will focus on in-situ resource utilization, ISRU. Engineers have developed a device to convert lunar soil into bricks using solar energy, enabling construction of habitats and infrastructure. This mission will also test 3D printing technology for building lunar facilities, potentially revolutionizing space exploration by reducing the need for Earth-launched supplies. China's ultimate objective is the International Lunar Research Station, ILRS, a permanent moon base planned for completion by 2035. This China-Russia collaboration will support long-term human presence with modules for research, habitation, and resource extraction. China is already testing life support systems and lunar solar power, which could generate up to 10 kilowatts per module. The ILRS aims to be a hub for scientific discovery and strategic dominance. Since 2004, China has launched over 60 missions, including the Tiangong space station. Its estimated $11 billion annual space budget trails only the US, and its Long March rocket series with over 400 launches is being upgraded for heavier payloads. Long March 9, under development, will lift up to 140 metric tons to low Earth orbit, rivaling NASA's Space Launch System and positioning China as a leader in heavy lift launch technology. The US is increasingly concerned about matching China's ambition, prompting NASA to expedite its Artemis program to land astronauts on the Moon by 2025. Meanwhile, China's Chang'e 5 mission successfully returned lunar samples in 2020, revealing insights into the Moon's volcanic history and potential resources, including rare helium-3 for nuclear fusion reactors. This new space race is about more than prestige. It's about strategic advantages in resource extraction, technological innovation, and military dominance. China's lunar goals align with its broader strategy to lead in technology and exploration, bolstering its economic and geopolitical influence. With high stakes and a critical phase ahead, China is a formidable contender in shaping humanity's future in space. The Moon may once again become a proving ground for global power, with China determined to leave its mark. Part 10. The Landers. To return humans to the Moon, NASA has enlisted SpaceX to develop the Human Landing System, HLS, a variant of its Starship rocket. Standing 50 meters tall, the HLS will transport up to 4 astronauts to the lunar surface and back, with a 100 metric ton payload capacity for extended missions. Starship's stainless steel structure and powerful Raptor engines, each producing over 2,000 kilonewtons of thrust, are designed to meet the demands of lunar travel. Its spacious interior will house astronauts, scientific equipment, and habitation modules. Yet SpaceX isn't the only contender. Blue Origin, founded by Jeff Bezos, is building its Blue Moon lander, capable of delivering 4,500 kilograms of cargo. Blue Origin's success with its New Glenn rocket in 2025 has solidified its status as a formidable competitor. Blue Moon's precision landing technology and robust BE-7 engines are engineered to handle the lunar environment. The race is on to see which company will land astronauts on the Moon first and meet NASA's timeline. SpaceX is testing its Starship HLS in Boca Chica, Texas, while Blue Origin is constructing a production facility in Kent, Washington. Both companies face significant hurdles, with SpaceX refining propellant transfer techniques and Blue Origin accelerating development timelines. The stakes are high. Securing a NASA contract and a foothold in the emerging lunar economy, valued at trillions, is the ultimate prize. SpaceX's Raptor engines and Blue Origin's BE-7 engines are central to their designs, embodying their technological ambitions. The lunar economy promises opportunities ranging from resource extraction to scientific research and tourism. The race's winner will not only gain NASA's support but also position itself as a leader in this new frontier. The competition reflects the historic US-Soviet space race, but this time, private companies are at the forefront. The rivalry between SpaceX and Blue Origin represents a shift in space exploration, driven by commercial interests and rapid innovation. The Moon's resources, including water ice in shadowed craters, could sustain human settlements and fuel future missions. Observation. The NASA private company collaboration marks a new era of space exploration. The Moon, once a distant dream, is now within reach, and these landers will enable humanity's next giant leap. This partnership demonstrates the power of public-private collaboration, leveraging the strengths of government agencies and private enterprises. The landers being developed today are more than just vehicles. They are cornerstones of a future where humanity's presence extends beyond Earth. Part 11. The South Pole Aitken Basin. The South Pole Aitken Basin is the largest and oldest recognized impact structure on the Moon, spanning 2,500 kilometers and reaching depths of over 8 kilometers. This ancient scar from the solar system's chaotic youth may have exposed material from deep within the Moon's interior, offering insights into its composition and formation. Estimated to be over 4 billion years old, it records a time when catastrophic collisions were commonplace. Geologists are eager to study this basin, as it may hold the key to understanding the Moon's early history. The basin's floor, rich in iron-rich minerals like olivine and pyroxene, suggests the impact exposed parts of the Moon's mantle. Samples from this region could provide the first direct evidence of the Moon's internal structure, while astronomers hope to place telescopes on the far side of the Moon to detect faint signals from the cosmic dark ages. The basin's topography is equally intriguing, with towering cliffs and permanently shadowed regions that may harbor water ice. These shadows are among the coldest places in the solar system, with temperatures plunging to 240 degrees Celsius. If confirmed, this water could be a critical resource for future lunar exploration, providing fuel, oxygen, and drinking water for astronauts. However, the lunar environment is harsh, with extreme temperatures, micrometeorite impacts, and constant solar radiation. Sunlit areas can soar to 120 degrees Celsius, while shadowed regions can drop to 170 degrees within a single lunar day. The lack of a substantial atmosphere also leaves the surface vulnerable to micrometeorites, striking at speeds exceeding 20 kilometers per second. Observation. The basin's central peak, Masalin Peak, stands as a testament to the impact's intensity. Rising over 5 kilometers, it is believed to be a remnant of the rebound of the Moon's crust and is rich in anorthosite, making it a prime target for future sample return missions. Interpretation. The basin's age and size suggest it was formed during the late heavy bombardment around 4 billion years ago. This event may have shaped the Moon's geology and possibly delivered water and organic compounds to its surface. Speculation. If water ice is present in the basin's permanently shadowed regions, it could serve as a resource for deeper space exploration, potentially reducing costs for missions to Mars or beyond. Additionally, the basin's unique geology could provide insights into the formation of other rocky planets, including Earth. Can we overcome these obstacles and unlock the secrets of the Moon's past? The South Pole Aitken Basin is more than a geological wonder. It is a time capsule from the solar system's infancy. To explore it is to journey back to the dawn of our cosmic neighborhood. Part 12. The Astronaut's Preparation. The Artemis II crew has spent years training for every aspect of their mission. They have rehearsed in advanced simulators that replicate the harsh conditions of space, from launch vibrations to precise docking maneuvers. Every action, from switching alarms to spacewalk contingencies, has been drilled until it becomes instinctive. These simulations test not just physical skills, but problem-solving, teamwork, and resilience under pressure. The crew has mastered the Orion spacecraft systems, knowing every component as intimately as their own bodies. In August 2025, the crew visited the Kennedy Space Center, a historic site of human spaceflight. They walked the 320-foot crew access arm, the path they will take to the spacecraft on launch day. This arm, suspended 30 stories high, symbolizes the bridge between past achievements and future ambitions. Standing at its edge, they gazed at the Orion spacecraft, a testament to human ingenuity. Photographed in their orange flight suits, they embodied the determination of a new generation of explorers. Their preparation extends beyond physical training. Mentally, they carry the weight of history. Christina Koch, who may become one of the first women to walk on the moon in the 21st century, represents the aspirations of countless women. Victor Glover, reviewing mission plans, understands that millions will watch, inspired by a crew reflecting humanity's diversity. This mission is more than a technological feat. It is a testament to the human spirit of exploration and unity. The crew has also undergone psychological training for the isolation and stress of space travel. They spent weeks in analog environments like the Human Exploration Research Analog, HERA, simulating confined lunar mission conditions. These exercises focus on thriving in environments with delayed Earth communication and independent decision-making. The crew has learned to rely on each other, trusting in their collective strength and shared mission purpose. Observation. The Artemis II crew marks a turning point in human space exploration. Unlike the Cold War-driven Apollo missions, Artemis is collaborative, with international partners contributing technology and expertise. This shift reflects a broader approach to space as a shared resource, emphasizing cooperation, inclusivity, and sustainability. Interpretation. The focus on diversity and collaboration in the Artemis program is strategic, not symbolic. A diverse crew is better equipped to solve problems creatively and adapt to challenges, inspiring a global audience. By preparing for every contingency, the Artemis II crew sets a new standard for human spaceflight, balancing ambition with humility and innovation with responsibility. Speculation. As the Artemis II crew stands on the brink of history, questions arise about the mission's impact. Will it inspire a new era of lunar exploration with permanent bases and scientific outposts? Will it pave the way for human missions to Mars? Or will it remind us of Earth's fragility and beauty, encouraging us to protect it? One thing is clear, the Artemis II crew is not just preparing for a mission, they are preparing to shape humanity's future in space. Part 13. The Science Payloads. Artemis II is more than a test flight. It's a scientific mission fueled by human curiosity and global cooperation. The spacecraft will carry 5 CubeSats, small satellites designed to answer long-standing scientific questions. These shoebox-sized pioneers, contributed by international partners, are packed with technology to advance lunar exploration. Germany's Tatchel will test the durability of electrical components in lunar conditions, enduring extreme temperatures from 150 degrees C to 150 degrees C. Argentina's Etenea will map the space radiation environment, providing critical data for designing lighter, more effective shielding for future missions. South Korea's CARISAT will study lunar regolith, the moon's dusty surface, to explore its use as a construction material. Saudi Arabia's Aramco SAT will test advanced communication technologies for maintaining contact with Earth, even from the moon's far side. As the crew continues toward the moon, these CubeSats will separate from Orion, deploying like glowing embers into the void. Each will collect data to deepen our understanding of the lunar environment, transmitting findings that could revolutionize future exploration. The Artemis Accords, signed by over 40 nations, promote peaceful lunar exploration through transparency, interoperability, and shared scientific data. Discoveries made by one nation will benefit all, potentially leading to advancements in solar panels, radiation shielding, and space medicine. What will these missions teach us? Could we uncover ways to harness lunar resources like water ice in shadowed craters? Might this lead to a permanent lunar base, a gateway to Mars and beyond? The answers could redefine our place in the cosmos, proving that humanity's reach extends far beyond Earth. Observation. The Artemis II. CubeSats will provide unprecedented data on the lunar environment, from radiation levels to regolith behavior in microgravity, fostering global collaboration. Interpretation. Successful CubeSat missions could accelerate technologies for lunar habitation, such as improved radiation shielding and regolith-based construction, making long-term missions safer and more feasible. Speculation. If lunar water ice is confirmed, it could spark a new era of resource utilization, transforming the moon into a supply depot for deeper space missions and reshaping our approach to space travel. Part 14. The Geopolitical Battleground. The moon is becoming a geopolitical battleground, blending national ambitions, rivalries, and uneasy collaborations. Analysts debate whether it mirrors historical territorial scrambles or represents a new era of cooperative discovery. The truth likely lies somewhere in between. China and Russia have rejected the US-led Artemis Accords, instead partnering on the International Lunar Research Station, ILRS. Russia's contributions are constrained by economic sanctions and a 10% budget cut in 2021, yet it remains symbolically invested. Nations like Pakistan, Venezuela, and several African countries are aligning with the Chinese-led effort, drawn by promises of technological and economic benefits. China's lunar ambitions are particularly aggressive. Since 2018, it has launched 3 missions, including Chang'e 5, which returned lunar samples in 2020, a feat unmatched since the Soviet Union's Lunar 24 in 1976. China aims to land astronauts on the moon by 2030, cementing its status as a space superpower with an estimated $13 billion in space spending by 2023. The US leads a coalition of over 40 nations, including Japan, Canada, the UK, and newer partners like India and Brazil. The challenge is fostering effective collaboration to establish a permanent lunar presence. The moon is more than a scientific frontier. It is a strategic high ground. Its resources, like polar water ice, could fuel missions to Mars and beyond, and controlling its surface raises concerns of a potential space Pearl Harbor. Observation, interpretation, speculation. The moon's geopolitical significance is clear, but its future is uncertain. Will it be governed by cooperation or divided by rival claims? The outcome may depend on who reaches the moon first and how they assert their presence. If China establishes a lunar base before the US-led coalition, it could set hard-to-challenge precedents. Conversely, broader support for the Artemis Accords could foster peaceful coexistence. The race to the moon is now about securing resources and asserting influence. Private companies like SpaceX and Blue Origin are accelerating the competition. SpaceX plans to launch its Starship rocket to the moon by 2025, while Blue Origin is developing its own lunar lander. These commercial ventures add complexity as nations and corporations vie for dominance in the emerging space economy. Every mission and discovery now carries strategic weight. The moon, once a symbol of human achievement, is a strategic prize. The choices made today will shape humanity's presence in space for generations to come. Part 15. The Rockets. At NASA's Michoud Assembly Facility in New Orleans, technicians are building the core stages for the Space Launch System, SLS, rockets. The SLS core stage stands over 200 feet tall, holding 733,000 gallons of liquid hydrogen and oxygen. Its 4 RS-25 engines, each as tall as a 2-story building, generate over 2 million pounds of thrust. This rocket is vital to NASA's Artemis program, aiming to return astronauts to the moon. Delays have pushed the SLS program's timeline, with the Artemis uncrewed test flight launching in November 2022, 4 years behind schedule, and each launch costing over $4.1 billion. At SpaceX's Starbase in Boca Chica, Texas, Starship production is accelerating. Stainless steel rings are welded into the ship's 160-foot body, and Raptor engines are continuously tested. SpaceX aims for Starship's first orbital test flight in 2023, a key milestone in its lunar ambitions despite prototypes exploding during tests. The company achieved the first successful landing and relaunch of a Starship prototype, SN-15, in May 2021. Blue Origin's New Glenn rocket, standing at 322 feet with a reusable first stage, is also a major contender. Blue Origin is developing the Blue Moon lunar lander for moon payload deliveries by 2024. The New Glenn rocket's debut flight is delayed to 2023 due to engine issues, and the company has secured a $3.4 billion NASA contract for its lunar lander. Observation. The lunar race is a logistical, economic, and technological challenge. SpaceX has invested over $5 billion in Starship since 2019, while Blue Origin commits $1 billion annually. NASA faces scrutiny over its budget and reliance on private partners. Interpretation. The success of SLS, Starship, and New Glenn will shape human spaceflight, influencing lunar tourism and research. They represent traditional government-led missions, private innovation with reusability, and a hybrid model. The next few years will reveal the prevailing strategy. Speculation. If SpaceX succeeds with Starship, it could transform the aerospace industry. However, if Blue Origin or NASA's SLS achieves key milestones first, it may validate a more methodical approach. A successful Starship program could open the door to Mars missions, while SLS and New Glenn might prioritize lunar bases. The outcome will determine whether private innovation or government-backed endeavors lead the future of space exploration. Part 16. The next few years. The coming years are pivotal for lunar exploration. By 2026, Artemis 2 will send 4 astronauts on a 10-day journey around the moon, testing systems for future landings and traveling 1.4 million kilometers, the farthest humans have ever ventured. The mission includes a flyby of the lunar surface, capturing high-resolution imagery of potential landing sites. Meanwhile, China's Chang'e 7 will land at the lunar South Pole, to analyze soil for water ice, and Draper's mission will study the far side's interior and surface radiation. Firefly Aerospace's Blue Ghost Mission 2 will explore shadowed regions, using robotic arms to collect samples up to 1 meter below the surface. By 2027, SpaceX aims to demonstrate orbital propellant transfer, a first-of-its-kind process essential for sending Starship to the Moon. Blue Origin may launch its crewed Blue Moon mission, carrying up to 4.5 metric tons of cargo, including rovers and instruments. The Lunar Gateway's initial modules, the Power and Propulsion Element, PPE, and Habitation and Logistics Outpost, HALO, will establish a permanent presence in lunar orbit, providing 60 kilowatt of solar electric propulsion and living space for a crew of 4. By 2028, Artemis 3 or 4 could land astronauts on the Moon, using the Gateway as a staging ground. These missions will deploy the Lunar Terrain Vehicle, a rover capable of traversing 200 kilometers. By 2030, astronauts from the US, China, or collaborative efforts could be living and working on the lunar surface, testing technologies like 3D printing with regolith for habitats, and preparing for a sustainable base. The European Space Agency's Argonaut program aims to send its first crewed mission to the surface by this time. Observation. The lunar South Pole is critical due to its water ice deposits, which could produce fuel and oxygen. Its near-constant sunlight allows for solar power, but extreme cold and rugged terrain present challenges. Temperatures in shadowed regions can drop to 240 degrees, requiring advanced insulation and heating systems. Speculation. Discoveries could revolutionize our understanding of the Moon's origins and its role in Mars exploration. Confirming water ice could enable a lunar fuel depot, reducing deep space exploration costs by up to 90%. Lunar infrastructure like habitats and power systems could support commercial ventures, including space tourism and mining. Companies like SpaceX and Blue Origin are already developing plans for lunar tourism, with ticket prices projected at $500 million per seat. Humanity is returning to the Moon, driven by science, technology, and geopolitics. What will we discover? Will the Moon provide resources that transform space exploration, or will challenges test our resolve? And how will these lessons shape our future as we look toward Mars and beyond? Part 17. The Final Countdown. The countdown has already begun. Astronauts are training in meticulously designed simulations, their every movement analyzed to ensure precision during the mission. In the sprawling facilities at NASA's Johnson Space Center, a full-scale mock-up of the Orion spacecraft sits beneath harsh fluorescent lights, its every switch and panel already worn from countless hours of practice. Rocket engines are being assembled and tested at the Stennis Space Center, where the roar of their thrust can be heard for miles, a thunderous prelude to the launch. On February 5, 2026, the Artemis II crew, Christina Koch, Victor Glover, Reed Wiseman, and Jeremy Hansen, will strap themselves into the Orion spacecraft and embark on a journey that will take them farther from Earth than any human has ever traveled, surpassing the 248,006 MVP 5-mile lunar orbit record set by Apollo 13. Their mission is a test, a rehearsal for everything that comes after, but it is also a statement of intent. The United States is returning to the Moon, and this time it plans to stay. The question is, can it succeed? And what will it take to win the new space race? The stakes are high, not just for national pride, but for the future of human exploration. Over 18,000 people are employed across NASA and its contractors to support the Artemis program, a workforce that spans engineers, scientists, technicians, and support staff. Their collective effort represents a $93 billion investment, the largest commitment to space exploration since the Apollo era. Yet, the true cost of failure would be immeasurable, a setback not just for NASA, but for the global ambitions of humanity in space. The answer lies not just in technology, but in human ingenuity, cooperation, and the relentless pursuit of knowledge. In labs across the world, scientists are developing new materials to withstand the harsh lunar environment, while engineers refine systems to extract water from lunar regolith, a process that could transform the Moon into a refueling station for deeper space missions. International partnerships are being forged, with 23 nations signing the Artemis Accords, a framework for cooperative lunar exploration that includes commitments to peaceful and sustainable activities in space. The Moon is waiting. It has been waiting for 53 years. And finally, we are going back. Finale. The Moon is no longer a distant dream. It is a destination, a laboratory, and perhaps one day, a home. The astronauts know this. They feel the weight of history on their shoulders. When Christina Koch looks at the Moon, she knows she may be one of the first people to walk on its surface in the 21st century, her boots leaving prints that could last for millions of years in the airless environment. When Victor Glover reviews mission plans, he understands that millions of people around the world will be watching, their hopes and dreams riding alongside the crew in the Orion capsule. This is their moment. This is our moment. The return to the Moon is real. The rockets are built, their towering frames casting long shadows over the launch pads at Kennedy Space Center. The spacecraft are tested, subjected to extreme conditions in vacuum chambers and thermal simulations to ensure they can endure the journey. The astronauts are ready, their training culminating in a 10-day mission that will see them orbit the Moon before returning to Earth, a critical step toward the Artemis 3 landing in 2027. All that remains is the countdown, and that countdown has already begun. The question that should occupy every thinking person is this: what does this mean for our species? Are we entering an era of expanded human presence across the solar system? Will the Moon become a platform for reaching Mars and the asteroids, a stepping stone to worlds beyond our own? Will we look back on this decade as the moment when earthbound civilization became a spacefaring civilization, when the first human footprints on Mars joined those on the Moon? Or will this be another false start, another burst of enthusiasm that fades when budgets tighten and attention wanders? The answer is up to us. The Moon is waiting. And this time, we go back to stay. The Artemis program is more than a mission. It is a promise, a commitment to push the boundaries of human achievement and inspire future generations. As the countdown ticks closer to zero, the world watches, hopeful and expectant. The Moon, once a symbol of the impossible, is now within our reach, and with it, the future of humanity in space.